Hey guys, happy ninth day of Christmas. And what I'm going to do today is I've put together a number of data representation videos which will help people with the GCSE syllabus. You can use them as revision videos for your students if you like. I've attached one at the end of this video, but if you go into my playlists, if you like this video, subscribe to my channel. But if you go into the playlist, you'll be able to actually watch the videos back, and these videos should help your students with the OCR syllabus. There's some of the things that I use when I'm teaching my students to kind of help them get on track for data representation. There's some tips in there for binary. There's some tips in there for sound. So there's just a little bit of a breakdown there that will help you with your students. So I hope that these videos that I am going to upload are going to help you. Like I said, go into my playlist. You'll be able to see a number of videos talking about data representation, including the binary shift, what happens when you move left and right. And I hope that they will be useful in your lessons. So thank you for watching. I hope you're having a fab Christmas. We've still got a couple of days left, and enjoy the rest of your holidays. Thank you for watching.
Hi there. So what I'm going to show you today is how you can use Office Mix to actually record into your presentations. And the first one of a series of videos that I'm going to do is on data representation. So it's how you display data on your computer, talking a little bit about binary. So moving forward, there'll be some videos in these slides, and there'll be a number of videos on my channel. So you should see me in the corner of your screen. So moving on. So the objective that I want today is that I want students to actually be able to actually understand that there are ways that computers represent data. Now, I'm going to show this slide to you because I want you to think back to primary school where you count in hundreds, tens, and units. And I want you to think about the place value of that. Because to begin with, you've got your units, which could be like 1 to 9. And then once you've gone to 9, it moves into the tens column, which you can see here. So what this table's saying here is how you've counted to 10 once, and then you've got 2 units, which is 12. And that's basically how the number system works. And you're gonna see that we work in a similar way with binary. Moving on to our next slide. The way that computers work is that they're made of millions of switches that turn on and off at such a speed that you can't see it happening. So I want you to think about these switches as zeros and ones. These are what we know as a binary digit, a 1 or a 0. Now, if you are asked in an exam what is meant by a bit, it's a binary digit. It's a switch within the computer represented by a 1 or a 0. Now, with this in mind, the impression that you can get from computer systems is that computers are very stupid in that they can only use ones or zeros. Now, moving on, this is the type of exam question that you would get in a GCSE computing syllabus. Now, you need to be able to explain why data is stored in a computer in a binary format. Now, moving on from that, so here's some think time, but moving on from that, circuits need to check for 2 states. So there's one way that you can get a mark for an exam question like that, because electricity is either flowing or it's not within the computer system. So that is either your 1 or a 0. Now, to extend that even more, you can talk about how this results in more reliable circuits, because you could imagine if you've got 4 or 5 outcomes, that's 4 or 5 outcomes that could go wrong. Whereas in binary, you've only got a 1 or a 0, which can go wrong. So that's something to bear in mind for the type of exam question that you might get at such an early stage. Now, binary, when you've got 4 bits of information together, this is known as a nibble. And what if you start from the far right and move your way up, you can see we're going 1, 2, 4, and 8. That is what we would know as a nibble. I'm just going to change the ink color now so you can see that. So that is what you would see as a nibble. Now, when we put 8 of those bits together, 8 binary digits, that is what we call a byte of information. So you can see what's happening here. This is working just like our denary system where we count from 1 to 10, because what's happening here is this is saying we've counted to 2 once, so I would have a 1 and a 0 here if I was representing the number 2 in binary. So it's pretty straightforward. Now, to convert from binary to denary, or denary, depending on how you pronounce it, you can convert it quite easily. Now, if I had to make the number 37, I would need to use a byte of information, most likely, okay, or 6 bits. And what I would do is I would need to turn on the 32, and then I would need to turn on the 4. So this would actually become a 1, and I would also, so that would make 36, I would also need to turn on, so let's scribble that out, the 1 here. So 32 plus the 4 plus the 1, that would be 1, 0, 0, 1, 0, 1. And that is how you would make 37 in binary. So that's relatively straightforward. Now, if I move to the next slide, you can see what it looks like. So you can have the 4 and the 1, so that leaves us 37. Now, here's some that you can try. What I recommend you doing at this point is maybe pausing the video, giving it a go, maybe using your grid where you go 1, 2, 4, 8, 16, 32, 64, 128, and so on. Start from your far right with the number 1 and work towards the left with the higher numbers. And remember to increase by 2 each time, because binary is a base 2 system, because you get either a 1 or a 0. If you want to try these out now, I recommend you pausing this video and then coming back to it. So here you can see the answers to those questions. So what we've got here is number 7 is represented by turning a 4, a 2, and a 1 on. Pretty straightforward stuff. Number 13, you can turn the 8 and the 4 on, which makes 12. Okay, then you can turn the 1 on, which makes 13. 28 is 16 plus the 4 would make the 20, plus the 8 is 28. 63, a little cheat for you. If you have to make a number such as 31, you would turn on all the switches after the next biggest number value. And then we've got 101, which is 64 plus the 32 plus the 4 plus the 1. And that is how you make those in binary. Now, there is another method you can do. What you can do is you can divide the number by 2 each time. So if you've got a larger number like 156, if I divided this by 2, you can see that 156 divided by 2 goes into 78, so that is 0 remainder. 78 divided by 2 creates 39. 39 divided by 2 is 19, and you end up with a remainder 1, not 0.5. 19 divided by 2 ends up with 9, and you end up with a remainder of 1. 9 divided by 2 is 4.5, so you get a 4 and a remainder 1. 4 divided by 2 is 0. 2 divided by 2 is the 1, and this is where this final 1 comes in. And what you do is you start at the bottom and start writing that number out. So 1, 0, 0, 1, 1, 1, 0, 0. Now I will try to do a writing video of this method another time so you can see how that works, but that is how you convert from denary to binary by using the division method. This is another way that you can see how it works. Notice you've got your least significant bit and your most significant bit. The most significant bit is always the value that will be your highest place value. So if I was to write this out, I would write out 1, 0, 1, 0, 1, 0, 0, 1, and that is how I'd get my answer. There are some worksheets available. Some of your teachers may give you different worksheets, but these are worksheets that I've given you before my students, and they will have access to those. So I hope this video has been a quick stop introducing binary, and enjoy the rest of the videos. Thank you for watching.